We shall see next problem now. Find an equivalent resistance between the terminals A and B using star delta transformation. The network is given as shown in the figure. Terminals A and terminal B is given here. All the resistances are 10 ohm. If you observe the circuit, you may get confused to know which is series or which is parallel. So what you have to do now is, you have to just reconstruct the network in such a way that it has to look either the circuit is having a delta form or it is having a star form. So what we shall do now is, we shall consider these two intermediate points as C and D. This has C and this has D point. Let us now redraw the circuit. Redrawing the circuit. This will be terminal A, correct? So if you observe, let us consider this as C terminal and this as D terminal. A to C, if you observe, there is 10 ohm. So the same 10 ohm, I will now replace it here. C to D, if you observe here, again there is 10 ohm. C to D, I will add this 10 ohm across C to D. Again D to B, I will write like this here. If you observe D to B, you have 10 ohm resistance. The same 10 ohm resistance I will write here across D to B. And again if you observe here, across A to D. Across A to D you have 10 ohms. So across A to D I will write it as 10 ohms. And again across C to B. This part if you observe, again it is 10 ohms. And this is terminal B. So now this is how, if you redraw the circuit, it will look like. C and D are just some intermediate terminals that we have assumed, but we need to find out the equivalent resistance across the terminal A and across the terminal B. So if you observe here, you have delta form. This is one delta form and this is one delta form, but 10 ohm is the common resistance that is connected between these two delta networks. But here you need to consider any one of the delta network. I will consider this one as delta. Now inside this I will draw one star network. I will name this as R1, resistance R2 and resistance R3. Now by using delta to star transformation method, you need to find out the values of R1, R2 and R3. If you again redraw this circuit, by applying this star network, the circuit will now look like this. Terminal A, here resistance R1 will be present. Terminal R2, resistance R2, resistance R3. This is connected to C and here it is connected to D. And this will be as it is, 10 ohm. So this is now this star I have just written here. This R1, R2 I have written here. Now you have to find out the values of R1, R2 and R3. So from star to delta transformation, what will be R1 and R2 and R3? Because all the resistances are 10 ohm. So you can clearly say R1 which is equal to R2 which is equal to R3 which is equal to 10 into 10 divided by 10 plus 10 plus 10, because all the resistances values here are 10 itself. So directly you can, the same, if you substitute for R2 also, you will be having the same term, same numbers. If you substitute for R3 also, you will be having same numbers. So that's why I have written R1 equal to R2 equal to R3, which is 10 into 10 divided by 10 plus 10. You will get 10 divided by 3 or 3.33 ohms. Now replace R1 by 3.33 ohms, R2 by 3.33 ohms and R3 by 3.33 ohms. Next, now you observe the circuit, how I can simplify. Now you have to check for parallel combination and series combination. Since you are finding the resistance across terminal A and B, the C and D will be just like a dummy nodes. So here this 3.33 and 10 ohm will be in. So if you observe this, this becomes a series combination. And these two resistances will also form a series combination. Now you need to add 10 plus 3.33. So this series combination will be 10 plus 3.33, which is equal to 13.33 ohms. And here also the series combination 10 plus 3.33, which is equal to 13.33 ohms. Now draw the circuit. A, here 3.33 ohms. Series connection I am reducing. So this becomes 13.33 ohms. This is also 13.33 ohms. And remaining terminal B. Now if you observe this part, this forms a parallel combination. So in parallel it will be 13.33 into 13.33 divided by 13.33 plus 13.33. You will get, so when you calculate here you will get 6.67 ohms. Now replace 6.67 ohms in series with 3.33 ohms. 6.67 ohms. Now these two will form what? Series combination. Add both the resistances. You will get 3.33 plus 6.67, which is equal to 10 ohm. So resistance across the terminals A and B is now 10 ohms, or RAB, which is equal to 10 ohms. This is the answer. We shall now go for the next problem. The same question. Find the equivalent resistance between the terminals A and B using star delta transformation. So this is the circuit that is given. So now first you observe the circuit. First always check for series and parallel combination if it is possible. If it is not possible, then you check for delta and star form in the network. So here if you observe this circuit, you have two resistances which are in series. If you observe these two resistances, 2 ohm and 4 ohm, 4 ohm and 11 ohm, these two will form a series combination. These two will also form a series combination. So in series you need to add the two resistances. This will be 11 plus 4, which is nothing but 15 ohms, and here 2 plus 4, which is equal to 6 ohms. Now you redraw the circuit again. When you redraw the circuit will look like this. The series combination I have just replaced, that's all. You got 6 ohms in series, that resistance I am writing here. And the remaining circuit will be as it is. This is 41 ohms, 17 ohms, 15 ohm, 15 ohms, and this is also 15 ohms. Now you observe the circuit again. There is no series and parallel combination that is possible. You check for delta and star formations. Star is not present here. You can clearly see from the circuit. But two delta networks you can identify. This is one delta network. And again this is one delta network. Now you redraw the star network within this delta network. It will look like this. Let us name this as R1, R2 and R3. This resistance is as R4, R5 and R6. Now you need to find out the resistances R1, R2, R3, R4, R5, R6 using delta to star transformation method. Now if you again redraw the circuit by replacing the star connection, the circuit will become even more simpler. I will now just rewrite the circuit. This is R1, R2 and R3, R4, R5 and R6, and remaining resistance will be as it is, 41 ohm and 17 ohm. Now first find out the values of the resistances R1, R2 and R3. It's simple. If you observe the delta transformation, all the resistances are 6 ohms. Now you can directly write like this: R1 which is equal to R2 which is equal to R3 which is equal to delta to transformation method will be 6 into 6 divided by 6 plus 6 plus 6. You will get 36 divided by 18, 2 ohms. Similarly, here also if you observe the delta circuit, all the resistances are having 15 ohm, 15 ohm and 15 ohm. So R4 will also be equal to R5 will also be equal to R6 because same resistances values are there. It becomes 15 into 15 divided by 15 plus 15 plus 15. You will get 5 ohm. Now write these values. R1 is 2 ohms, R2 is 2 ohm, R3 is 2 ohm, R4 is 15 ohm, R6 is 15 ohm and R5 is 15 ohm. Now again you observe the circuit. Now it's simple. These three will be in series combination, and again these three will be in series combination. So in series you need to add all the resistances. It becomes 2 plus 17 plus 15. You will get R4, R5, R6 you got 5 ohm. Sorry, I have written here 15 ohm. This is 5 ohms. So in the series, when you add these resistances, 2 plus 17 plus 5, you will get 24 ohms. Similarly, here you add 2 plus 41 plus 5, you will get 48 ohm. Now you again redraw the circuit. A terminal resistance R1, which is 2 ohms here. Series combination you have done. So this is 48 ohms. And this series you got 24 ohms. And write the remaining circuit 5 ohm. Now you again observe the circuit. So these two will form a parallel combination. So 48 into 24 divided by 48 plus 24, you will get 16 ohms. Now finally you draw the last circuit, 2 ohm, 16 ohms. The answer you got by parallel combination, and 5 ohm. So now all these three resistances will be in series. Add all the resistances, 2 plus 16 plus 5, you will get 23 ohm. So final across A and B, the equivalent resistance now is 23 ohms, or RAB, which is equal to 23 ohm. So this is the answer.